All right, ladies and gentlemen, let's look at some examples. Now, when you do these, the directions will tell you to use the quantities indicated without the Pythagorean theorem, which basically means if you're not allowed to use the Pythagorean theorem, then it's one of our three special types of triangles, either a 45-45-90, a 30-60-90, or a 3-4-5. And that's really the first thing you got to figure out is what type of triangle it is. Now, excuse me. Once you figure that out, I would label the sides of the triangle with respect to what's the hypotenuse. If it's a 45-45-90, what are the, label the legs. If it's a 30-60-90, what's the short leg, what's the long leg, and then we can look at the relationship. If it's a 3-4-5, look at what the angles are with respect to the 3 side, the 4 side, and the 5 side. So let's look here, and if you notice we have a right triangle, a right angle, and we also have a 60-degree angle. So if you don't know what the missing angle A is, then remember the angles of a triangle have to add up to 180. So if you take 180 minus 90 minus 60, the missing angle there should be 30 degrees, okay? Also, if you just know that a 30-60-90 triangle, that gives it right away. If this is 60, that this has to be 30 right here. So I'm going to go ahead and write that in because it doesn't hurt to write stuff in on these triangles. Now, if you have your book, don't write your book, please, but you can make a quick sketch on paper. So, ladies and gentlemen, it's a 30-60-90 triangle. And therefore, I'm going to write that up here so we know that. This is a 30-60-90 triangle, okay? So, that means that, let's go ahead and write in what we know about the triangle then. Well, I know that the side opposite the right angle, the one that's marked 12, would be the hypotenuse. And I'm going to use abbreviations, okay? Then, the short leg would be the side opposite 30. So this is the short leg, okay? And then, the remaining side opposite the 60-degree angle is going to be the long leg. So I would always write those in because then it helps you to see those relationships better. So now let's go ahead and find A and B. Well, A ends up being the short leg. B ends up being the long leg. So we know the hypotenuse. We've been given that. So what's the relationship between the short leg and the hypotenuse? Well, if you remember, ladies and gentlemen, the short leg, the hypotenuse is equal to the short leg times 2. So we know the hypotenuse is 12. And you just fill this in. We know the short leg we're trying to find is A, and we're going to take that times 2. So basically all you're doing is solving a one-step equation now, or you can be able to just divide by 2, divide by 2. So that means A has to be equal to 6. And it says round to the nearest tenth if necessary. We don't really need to here because we don't have a decimal. But I guess maybe we will put the 0 there because it's 12.0 there. So we'll just put that. I wouldn't count it wrong if you had just 6. Now let's find the long leg. Well, remember everything, ladies and gentlemen, we now have the short leg. Everything in here is based off the short leg in a 30-60-90 triangle. So, ladies and gentlemen, we know that the long leg is equal to the short leg times the square root of 3. That's our relationship. So, if you take the long leg, which we're trying to find, that's B, that's equal to the short leg, which we found out to be 6, and we're going to take that times the square root of 3. Now, you can use the decimal value here. Just go ahead and put the square root of 3 into your calculator, and you get something like 1.732. You get a big long decimal. Okay? And then just multiply that by 6. So if you do that, you get, ladies and gentlemen, 10.392. And yada, yada, yada. Now it says round it to the nearest tenth. Well, the 9 here rounds that 3 up to a 4, so it's 10.4. Now I would just do one quick little thing. I would make sure, because if you made a mistake somewhere, then you may have the short leg being longer than the long leg, which it shouldn't be. So I would just take a look here. We know the 30 is right. A has to be smaller than B. And it is. 6 is smaller than 10.4. The short leg has to be smaller than the long leg, and they both have to be shorter than the hypotenuse of 12, which they are. So if we've done that correctly and we've double checked, you've done all this. We did that without having to use the Pythagorean theorem. Now, if you were on a test or something and you did this, well, it would be hard to use the Pythagorean theorem because you only know one side, the hypotenuse. You got to know two sides in order to use the Pythagorean theorem. So let's look at one more quickly here, and then we'll end this part of the video. So here we go. So this time, if you take a look, ladies and gentlemen, we have a right triangle. We have a 45-degree angle. Now again, if you want to find the missing angle, F, you just take 90 minus 45, or excuse me, I'm sorry, you take 90 plus 45 and subtract from 180. Or you got to know if this is 45, this has to be 45 also. So what we have here, ladies and gentlemen, we have a 45, 45, 90 isosceles right triangle, which tells us these two sides here are the same length. Okay? Now I'm going to erase a little bit of this because it's kind of confusing. If you put too much stuff in there, it can be confusing. And so what I'm telling you is, this is a leg, this is the leg, and this is your hypotenuse. All right? The two legs are equal. So right away we know a couple things. We know that F is 45 degrees. And I also know that D and E D is the same length as what we're given here for this leg, 6. So I'm just going to write that in there because, again, these are ladies and gentlemen, these two sides here are equal. Okay? Now, to find the hypotenuse, you got to know the relationship. So the relationship between the hypotenuse and a leg in a 45, 45, 90 triangle is the hypotenuse is equal to a leg, the length of either leg, because they're the same, times the square root of 2. Well, again, fill in what you're looking for. The hypotenuse is E. That's equal to the length of a leg, which we found out to be 6. And we're going to take that times the square root of 2. Well, again, you can use a decimal for the square root of 2. If you put that into your calculator, it's about 1.414. And then you take that times 6, then that is approximately 8.4852. And then again, we're only rounding to the 10th. So if you do that, ladies and gentlemen, this right here, this 8 will round that 4 up to 5, and you get 8.5. And then you just do a quick check again, just to make sure, because if you made a mistake, you're going to end up with sides being longer than sides that are supposed to be shorter than. So the two legs are both 6, that's fine. The hypotenuse should be longer than either of them. It is, it's 8.5, and we're good to go. And we found all the sides here. Again, we could not have used the Pythagorean theorem here. Well, we could have. It would have been more difficult because knowing that 6 and 6, then you can use the Pythagorean theorem to get your hypotenuse. But look how much less work it is if you know that relationship. Okay? We'll look at our last two examples on the next video.